Hey, welcome! Behind every single light switch and outlet in your house, there's a whole set of rules, a safety code that's designed to keep everything, well, safe. But let's be honest, that code can seem super complicated. So today, we're going to pull back the curtain and make sense of it all. So here's what we're going to cover. First, we'll touch on the absolute basics, your home's electrical lifeline. Then we'll dive into the official rulebook and decode what it's telling us. We'll look at the standard for copper wires, see how aluminum is different, and then tie it all together by explaining why this stuff really matters for a safe home. All right, let's start at the beginning. We flip switches and plug in our phones all day, every day, without a second thought. But what is actually going on inside our walls? That's what we're talking about when we say your home's electrical lifeline.
I'm sure you've been there, right? You're vacuuming, maybe the microwave was on, and boom, everything goes dark. You're heading down to the breaker box. Well, that trip breaker isn't an annoyance. It's actually a safety feature doing its job perfectly. It's protecting a specific part of your home's electrical system, and that part has a name.
It's called a branch circuit. Just think of a tree. The main trunk is your electrical panel, and the branches reach out to different parts of your house, feeding power to a group of outlets and lights. Seriously, understanding this one term is the key to everything else we're about to get into.
Okay, so if a breaker trips because there's a problem on a branch circuit, how do we know the right way to build those circuits in the first place? You guessed it, there's a rulebook for that.
And here it is, the National Electrical Code, or the NEC for short. Now, this isn't some dusty old book nobody reads. It's the gold standard for electrical safety, constantly updated by experts to protect all of us from things like fires and electrical shock. It's the source for everything we're talking about today.
And the best part is, we don't have to read the entire thing. The NEC has these awesome summary tables, and we're going to zoom in on one in particular, Table 210.24. Think of it as the ultimate cheat sheet for the most common circuits you'll find in any home.
So what's really fascinating is that this all comes down to one core safety rule. You've got three key players that have to work together perfectly: the circuit's rating in amps, the thickness of the wire, and the breaker that protects it all. The rule is simple. They have to match. Now, to really see this in action, let's start with the most common type of wiring in modern homes, which is copper. There's a reason it's the standard, and it gives us the perfect baseline to understand these rules. And here it is, straight out of the code. This table is just brilliant in its simplicity. Take a look at that first row. For a 15-amp circuit, you need a wire that's at least 14 gauge, and it has to be protected by a 15-amp breaker. See that? It's a perfect match. Same for the next one. 20 amps, 12-gauge wire, 20-amp breaker. Everything lines up. Let's make this totally real for a second. That 15-amp circuit, it's probably the most common one in your house. It's powering the lights in your bedroom, the outlets you plug your charger into. And according to the code, that circuit requires at minimum a 14-gauge copper wire, and it's all watched over by that 15-amp breaker in the panel. It's simple, it's safe, and it just works. Okay, here's the one little thing about wiring that can be kind of confusing: the gauge number. It works backwards from what you'd think. A smaller number, like 12-gauge, is actually a thicker wire than a 14-gauge wire. It's a little weird, I know. Just burn this into your brain: smaller number, thicker wire. All right, so we've got the rules for copper down pat, but what happens if a totally different material is used for the wire? This is where it gets really interesting, especially if you live in a home built during a certain time period. Let's talk about aluminum.
So here's the same kind of table, but this one's for aluminum wiring. At first glance, it looks pretty similar, right? The circuit ratings and breaker sizes are identical, but look really close at that middle column, the one for the conductor size. Do you see what's different?
And bam, there it is. This is the whole point. For the exact same 15-amp circuit, if you're using copper, you can use 14-gauge wire. But if you're using aluminum, the code is crystal clear. It must be 12-gauge. It has to be a thicker wire. So, why? Why does the code make this demand? Why does aluminum need a thicker wire? This isn't just some random arbitrary rule. It gets right to the very core of what keeps our homes electrically safe. Let's connect these dots. It really all boils down to one word: conductivity. Simply put, copper is just better at conducting electricity than aluminum is. So, to safely carry the exact same amount of electrical current without getting dangerously hot, an aluminum wire just needs to be physically bigger. It needs to be thicker than a copper one doing the same job. This chart just lays it out perfectly. For our standard 15-amp circuit, copper gets the job done with a 14-gauge wire.
But for aluminum, to do the same job safely, it has to step up to that thicker 12-gauge wire. Using the wrong size here isn't a small mistake, it's a serious fire hazard, because that undersized wire could overheat.
So if we put it all together, the most crucial thing to remember is this. The system is a chain of safety. The breaker is there to protect the wire is there to power the outlet, and everything, the breaker, the wire's thickness, and the wire's material, has to match up perfectly according to the code.
So what are the big takeaways today? First, you have to match the breaker to the wire size and its material type. You can't forget that second part. Second, remember that the material, copper versus aluminum, totally changes the rules for thickness. Third, the National Electrical Code isn't scary. It's your friend. It's there for your safety. And finally, keep in mind that these are the absolute minimums.
And that really just leaves us with one last thought. You know, this code we just demystified, it isn't just theory in a book. It's physically running through the walls all around you right now. So the real question is, do you know what's connecting the outlets in your home? Thanks for joining me.